Well, thank you for having me. Before I get started, this is joint work with Paul Devereaux, who's a longtime co-author of mine, Peter Lundberg and Kaveh Mazlasi, who are more recent co-authors. Kaveh was a grad student of mine at UT who does some really interesting work on household finance, so I recommend you check out his work. You should check out all of our work, of course, but Kaveh you may not have heard of, and he's awesome. And so, as I mentioned, or as was just mentioned, I'm going to be talking about intergenerational mobility in terms of wealth. So, just to give you an overview of kind of my research more broadly, we start with the quote, "The most important decision you will ever make is choosing the right parents." And I don't know who said that. Paul and I say it, so but I think it's been said a lot. And I think the research has shown that parents really do matter. And so the environment you grow up in, all these things are really important in terms of your long-run outcomes. And the things that we've been really focusing on for the last almost 20 years is really understanding kind of what the mechanisms are and trying to understand kind of why do we see these patterns. And frustratingly, we have not really nailed this down, and we find a lot of things matter a little, but overall, parents matter, and we're not quite sure what it is about them. And when I talked to my sister, I remember I had a paper on school starting age, and she said, "Well, should I hold back my nephew? Noah, should we start early, or should I? Someone said you had research on this." And I was like, it doesn't matter. Like, he's going to be fine. Like, he's your son. He's going to do okay. And I knew that's not really the answer that she wanted, but it's kind of like that's where the research is. It's like we're trying to understand what it is about it, but we know that the parents matter. And so the question that we try to answer in this paper is, what is the role of nature versus nurture in the intergenerational transmission of wealth? And so we're focusing on wealth and trying to distinguish kind of, is it that you're just genetically different and you're born and you're going to be successful and wealthy because your parents have those genes, or is it something about the environment? And so this relates to a famous conversation that never happened, where Fitzgerald said, "The rich are different than you and me," and Hemingway said, "Yes, they have more money." And this kind of reflects the two extremes. One is that rich people are inherently just different people. And so I'm reminded when the president said that who would want poor people to be in the cabinet? Like, you want your cabinet to have all rich people because they're the successful rich ones. I think that's kind of the Fitzgerald view of it. And Hemingway is basically saying, well, it's just that they had these advantages, that if you gave anyone these advantages, they would do better too. And so, again, this is kind of what we're trying to distinguish in this paper. I think people inherently kind of care about wealth inequality. There's a lot of reasons that we might. Wealth inequality is really substantial, larger than income inequality. And in the US, the median net worth of upper income families doubled in the 30-year period, but declined for lower income families. So wealth inequality is rising. We know that it is correlated across generations, so there's substantial persistence, and there's a lot of different papers that have looked at this. So this is just an example of one of the more heavily cited papers. Charles and Hurst used, I think it was PSID data, and find intergenerational wealth elasticities of about 0.37 for net wealth in the United States. So wealth is more persistent across generations than income. And I think recent work by Piketty, I guess it's not so recent anymore, but feels recent to me, that has kind of renewed interest in our understanding of wealth, that kind of this wealth inequality is a fundamental element of inequality in our society. And so what our paper is going to do is try to think about, is it nature or nurture or some combination or interaction of the two that's driving this correlation. And the way that we're going to do it is to look at adoptees. And I think this is really important if you're to inform policy. So if you think about a policy that would, for example, tax wealth or tax inheritances, this kind of says what the longer run impacts are going to be. So will it kind of rebound because I'm rich, but my kids are going to be rich no matter what, so if we tax away my wealth, they'll end up getting it back? Or is it just going to kind of disappear, and the next generation just won't have it. So I think that's kind of interesting. So why do we think that nature or nurture might matter in terms of this intergenerational correlation? Well, in terms of nature, and I have to apologize, I'm going to be pretty loose about what I mean by nature. So when you think about it, you kind of think about genetics, but we're a little bit looser than that, in that we're thinking about all pre-birth factors. And so there is a little bit of environment in there, in that I even have my own research suggests that things that happen to you while you're pregnant affect the long-run outcomes of children. So in utero experiences can be very important for kids. And that's going to be picked up in our pre-birth, in our nature measure. So it's anything that happens before birth. So how might that work? Well, if skills are genetically transmitted, or preferences for risk or entrepreneurship or something like that, if those things are genetically transferred, then you might expect that that's what's driving these differences in wealth. Okay? Environment, it's a lot easier to think about and think about manipulating, of course. There are a lot of ways that it could matter. So one of the most direct is just money means you can invest more in your kids. So I have more wealth, I can give them more opportunities, send them to better schools, help with their career. So I have all these networks, and recent work by Leah Bustan and co-authors is really interesting. It looks how a shock to wealth affects the kids in the long run, and shock to parental wealth, and she finds that it kind of, even though it has maybe a negative effect initially, the kids actually come back and catch up. So that's kind of interesting. So help with their career, and one of the arguments behind that is that they're helping with their career. It could be that attitudes towards risk and savings are a learned component. One of the most obvious is you can just give them money, right? So either loans to facilitate their own wealth accumulation, or just literally giving them wealth. And so for all these reasons, environment could matter. It's difficult to distinguish the effect of pre-birth from post-birth factors. And why is that? Well, it's because the people who are your pre-birth parents are the same as your post-birth parents, and so they're moving together, so you can't distinguish them. And so that's why looking at adoptees provides this really kind of cool way of thinking about separating genetics and pre-birth factors from environment. Okay, so what we do in this paper is use administrative data on the net wealth of a large sample of adoptees, as well as the own birth children born in Sweden between 1950 and 1970, merged with similar information for their biological and adoptive parents. And using this data, we first distinguish the role of nature versus nurture in the transmission of wealth, and then we try to get at some of the mechanisms. And this, I really believe what we find here. I think this is very suggestive. And then I have some new results at the very end that I'll present, where we put this in context of what we know about intergenerational mobility more broadly. So how is wealth different from income, from education, in terms of nature versus nurture? And you'll see kind of an interesting pattern emerge. Okay, so, and just to highlight why I think what we're doing is so cool, which is weird, but I do think it's really cool. The cool thing about Sweden, and you may be wondering, why are you doing Sweden? Well, we're doing Sweden not because we inherently think that learning about Sweden is the most important country to learn about, but interestingly, between 1950 and 1970, they recorded both the biological and adoptive parents of every child who was put up for adoption. So it's really rare to be able to follow the biological parents as well as the adoptive parents. So that's one of the features of what we're doing. And just to give you a preview of what we find, pre-inheritance, the wealth of adopted children is more closely related to the wealth of their adoptive parents. So it's environment that seems to matter more than biology. They both matter, but environment matters more. And once we take into account bequests, so inheritances, so this is pre-bequest. Most of what we're doing is going to be before your parents die and give you inheritances. Once you take bequests into account, it becomes, a lot of adoptive parents. It becomes much more environment because there is a huge role for bequests. So just literally giving your parents giving you their money when they die is a large part of what's going on. When we try to look at mechanisms, these effects are due in part to children's education and earnings, that it seems like wealth affects children's education and earnings. And then there also seems to be a role for differential asset allocation, that the way that they're allocating assets into risky versus non-risky seems to be doing something of what's going on. Interestingly, we thought we would find something. We're able to look at the savings rate, and you might think, oh, well, if you're wealthy, you save more. You teach your kids to save, and that's what's determining it. It actually works the opposite. So savings works in the opposite way, in that people who are very wealthy, their kids save less, which makes sense if you think your parents are there to kind of help you out or give you money at some point. So that was kind of an interesting finding, because it unexplains our results, basically. Okay, so here's the outline, and I will not spend a lot of time on these things, just to give you an idea of where we're going. I'll spend some time in the talk talking about the institutional background, because really understanding how adoption works in Sweden is really important for our analysis. I'll spend some time talking about data, the basic results and gender splits, and then focusing on inheritances, which I think is really interesting. I'll spend, even though it's not a reasonable amount of time, talking about mechanisms, trying to understand why, what is it about environment that matters. And then this is the list of specification checks that I probably will not go over. I didn't put tables for them, just so you don't panic that this looks really boring. But things that we do think about are what is it, which components of wealth matter, what happens if we include pensions, are adoptees randomly assigned, and I'll talk about that because obviously they're not randomly assigned, hopefully, for them. Ages at measurement of wealth. I might present something on this just because there's some really cool findings that it doesn't seem to matter when you measure wealth. And that was a really surprising finding for us. So if you measure the kids when they're 30 versus when they're 50, we know that wealth is increasing over this time period, but our results really don't change. And that I thought was pretty interesting. And it's in part because we're using your rank within your cohort. And so, but it does suggest that your relative rank is pretty constant or not changing that much over time. And that's what other people have looked at, but it's a very striking graph, so I'll hopefully show you that. Other things we think about are different transformations of net wealth. So we're going to use rank, but then some people really hate rank. And so we also do things in logs and levels. For a number of reasons, we think those aren't as good, but we get the same conclusions. Common geographic shocks. The nature versus nurture interactions, just to preview, we don't really find anything with that. We thought that would be really interesting. In more recent results that are in the paper yet, we spend a lot more time thinking about nature and nurture interactions. And we really cannot find anything. Now, does it mean there aren't interactions somewhere? It could be, but it's just, we're not able to find any. And then the last thing is this cool new graph that I have where we look at how wealth fits in with other outcomes. And it seems like wealth is really more environment, whereas things like schooling and education, which have maybe more of an ability component to it, has more biology. And so we have a graph, and that's some of our brand new results. Okay, so there's a number of related literatures. Again, this is a very small subsample of all the work that's been done. There's been work documenting correlations of wealth across generations, and there are these big correlations. There are people who have tried to look at nature versus nurture, not for wealth specifically, but looking at savings. The Cesarini et al. Paper is, I think, one of the best on this. But it's using twins and this decomposition of making assumptions about the genes versus the environment. It's called the ACE model, so I don't know if everyone's familiar. I was not familiar with it before. And it's really interesting. it makes some assumptions, but we're making some assumptions too. They actually find, so most of theirs is not looking at wealth. They have one result that looks at wealth. They find a larger biological element, which I thought was interesting. When we do something similar to that type of analysis on our data, we still find that it's environment. So it isn't just a methodological difference. It has to be something else going on there. Most closely related, I think, are the Swedish adoption studies. So while I wish that I could take credit for having come up with this idea, I did not. I think the first paper that I know of that used this large data set was the Bjorklund, Lindahl, and Plug paper in 2006, where they did it looking at schooling and income and found kind of a strong biological component. And so that was, I think that was kind of an amazing study that came out. Since then, because it's such a cool thing, a lot of other papers have come out. The shameless plug is that we have another paper looking at risk allocation in terms of assets. So if you were interested, you should check that out. But there have been a number of papers doing this. So we are definitely not methodologically innovating here. That being said, I think it's a really good tool to use for answering this question. And then there's one paper that actually came out around the same time that our first draft came out, which pains me to think of how long ago that was, that looks at Korean adoptees in Norway and tries to separate nature versus nurture in wealth. And so the downside is with theirs is that they're looking at Korean adoptees in Norway as opposed to Swedish adoptees, so there might be differences on that dimension, but also they don't have information on biological parents, and so, but their findings are consistent with ours, and so we view the papers as complements. Okay, so adoption in Sweden. So this was really interesting to me, not knowing much about it, but during the period, 1950 to 1970, adoption of small children was done anonymously. There was also no private adoption, so everything went through the state, okay? And that's how we have this great data. So because it went through the state, we know the biological mother and in many cases the biological father. And so we're able, and because we know them, we can actually track them and their wealth long into the future. In order to adopt, the criteria was somewhat stringent. So you had to be married and at least 25 years old, have appropriate housing. The father had to have a steady income and the mother had to be able to stay home with the child. So it's a little bit dated, I think. And you also had to be tested for sexually transmitted diseases. So these were the standards. What you might take from that is that our sample of adopting parents is not a random sample of the population. So it is a positively selected sample. That's my next point. So the issue is what we would like from adoption is that children are randomly placed into families. Okay? Our ideal experiment in a weird, horrible world would be you take kids and you randomly assign them to parents and then you can study them. So first, our first limitation is they're random, that they will be only assigned to parents who are eligible for adoption. Okay, so we already have a select sample. For that, to think about that, we actually look at how adoptive parents treat their own kids for the kids that actually are born to parents who also adopted a child, so it's about 500 kids. And it looks like they treat their biological kids like the rest of the population treats their biological kids. So it doesn't look like, at least on that dimension, that they're different. But they are observably better than the general population in terms of earnings and education. The other thing is that, how are children allocated to adoptive parents? We don't actually know. And so this is a limitation of what we're doing. There is some evidence from talking to people that the way it was allocated was parents were, they tried to match them based on appearance because they wanted the kid to look more similar to the adoptive parent. And so our concern is that they're matched based on not even their biological parents' wealth, because we can control for that, but something that is correlated with kids' outcomes in terms of wealth, and also correlated with something else about the biological parent. that we're not able to control for. So this omitted variable bias that we're worried about is that there's something else. The fact that we can actually control for biological parents' wealth, it makes this a lot less worrisome. And so in the paper, we spend a painful amount of time thinking about this. Yeah.
Hi. So, was there a preference by the adopted parents to have a boy or a girl, or was there any selection there?
So we can't see anything about the adoption, unfortunately, so we don't know. And in fact, we know that about 80% were adopted within the first year, but we don't know anything about individual adoption, so we don't know anything about preferences. We don't really find differences by gender, so that might kind of suggest that there's not something different going on in those families, but we can't tell kind of how the adoption actually, how the matching process worked.
And do you know if the kids were told they were adopted?
We don't know. So all we know is that at age 18, they have a legal right to know if they are adopted, but I don't know kind of how that happened. Yeah. Okay. And so most of the kids actually went pretty quickly into adoptive homes. So it's not, there wasn't a long lag. One of the things in terms of being in a nursery or something in the interim, the fact is that if these things are going on, so if you are staying with the biological parent longer, or if you're in a nursery, that would suggest kind of a downward bias on our environmental effect, because you're not in the environmental family as long, and we actually find bigger effects for the environmental aspect. So it seems like, if anything, this would suggest we're getting an underestimate. Okay, so the empirical specification is not that interesting, because it's really the experiment that we're thinking about and that we're estimating is, I'm a child and I have a biological parent and I can see their wealth, and an adoptive parent and I can see their wealth, and I see what's the correlation between my adoptive parent's wealth and mine, and what's the correlation between the biological parent's wealth and mine. And so if the biological parent's wealth is more important, we'll have a bigger coefficient. So we're comparing kind of the relative sizes of these coefficients. And then we're going to compare this to the full sample of not adopted kids, where we have a lot more kids, and see how does that compare to just that intergenerational correlation that we see. And the specification that we're going to use is based on your rank within your cohort. So it's how your wealth ranks relative to other people of your age. And so because of that, the fact that parents are different ages doesn't seem to matter too much, because it's their relative wealth within within their cohort. But as I said, we tried other specifications, and our results are really insensitive to that. Okay. And then we have other controls for year of birth of parents, which don't seem to matter because of this rank specification. Year of birth of children, again, doesn't seem to matter, and then gender of the child. So we're not controlling for a lot. And we also have the county of residence of the parents at age in 1965. Okay, so identification is really what I've said. It's important that adoption happens at early ages, because if you're not really living with your adoptive parents, you wouldn't really expect them to have an influence, and we think that this is true. And we also need for adopted children to be kind of not being assigned to parents based on the biological parents' wealth. And it actually can be wealth, but it can't be things that are correlated, but also correlated with the child's wealth. So, as I said, we spend a lot of time in the paper talking about that. Okay, so the data that we have are really cool. It's the Swedish Wealth Register, and so this is a pretty new data set. The nice thing is it was collected because they have a wealth tax, and so it was collected really well. And so they cared about it a lot. The downside is they eliminated this wealth tax in 2007, and so they stopped collecting the information. So we have data on wealth from 1999 to 2006, but it was actually reported by the banks and financial institutions and things like that. So there's not a lot of measurement error. And it's basically all assets that you have, including housing wealth. And as I said, we checked to see if this is driven by, because housing wealth is probably the most poorly measured in terms of kind of it's an assessed value of the house if the house wasn't recently on the market. And so it could have measurement error, but it isn't being driven by housing wealth. And then we have all kinds of information about the kids and the parents. Because you have to be in our wealth data to be in our sample, all the parents have to be alive in 1999. And then we also, and we're going to measure parents' wealth in 99 and children in 2006 to make the kids as old and the parents as young as possible. And then we let one parent die, but if both your parents die, we don't include you because then you're going to probably be getting bequests or inheritances. But then we also do a check to see if what happens when we include those people back in. And what you'll see is it just blows things up. That inheritances are huge in terms of intergenerational mobility. Okay, so this is the data. Let's see. I'm going to quickly go through this. Basically, this is in Swedish kroner, so divide by about 10, and that's US dollars. And the way this is presented, this is home birth children, so this is 1.2 million kids who were born and kept by their parents. This is adopted children, so we have about 2,500 adopted children for whom we know the parents and have all the relevant information. You can see this is kind of the sample population of biological parents, so this is, they're about at the 50th rank, or halfway there. The biological parents of adopted kids tend to be negatively selected. So they tend to be younger, less educated, and poorer. I don't think this is surprising. We spend some time in the paper kind of adjusting for these different things because adoptive parents, as I mentioned earlier, are positively selected. And so their education is slightly higher than the population as a whole, and their wealth is slightly higher. And so here is basically the full sample of our data, and this is just the correlation. So this is the 1.2 million data points. And if you just graph the correlation at each of these things, each of these points, what you see is that as your rank of parents goes up, the rank of children is going up, so they're positively correlated. What's interesting, and this isn't new to us, is that you see this negative dip at the beginning and a positive spike up at the end. This has been pretty well established. And this is because these are people with high negative net wealth, and you have to be pretty rich to get that poor, basically, because nobody's going to loan you $2 million to go in debt if you have no money. And this has been already studied, kind of shown that at the top, the persistence is even higher. What we're going to do with most of our results is present both the untrimmed but also trim our data. And this is because we're trimming the top and bottom 5% because this is an approximately linear model. And so it's just fitting our data. We try, as I said, we try to do the nonlinearities and look at them. But because we only have 2,500 observations and our biological parents are kind of down here and our adopted parents are up here, we can't do too much on that. So this is when we look at, this is basically the results, if you're a visual person, which I am not. This is the same graph where we're looking at biological parents' rank and the adopted children. And this is adopted parents' wealth rank and the rank of the adopted children. And so if you look at this and so what we're going to end up doing is trimming the data because there's those things. You can see that the standard errors, this is the confidence interval, are much bigger down here for the adoptive parents because we don't have a lot of adoptive parents at the bottom. And for biological parents, they're wider up here because we don't have a lot of biological parents at the top. So when we trim the data, if you look at this, you could see, I do not personally see it, that the slope for this is more positive than the slope for this. If you cannot see it, then you can see here in our results. So this is for the full sample of biological children who are raised by their own parents, and this is the trim sample, and this is for the adoptees. And basically what you see is that the adoptive parent coefficient is more than twice as big as the biological coefficient. And even when you trim it, it brings them closer, but it's still much bigger and statistically different for the adoptive parent. And this is basically our main set of results, is that what seems to be going on is that the environment matters more. And so from now on, we're just going to kind of move from this point. But this seems to be kind of the primary conclusion of the paper. When we break it into males and females, we don't really find, there's some difference, but they're not statistically different, and we don't actually have any prior about why they should be different. So it wasn't like we expected one to be different, and they weren't. The interesting thing when we consider inheritance, so now we're letting both parents die. So again, both parents have to be alive in 1999 for us to know their wealth, because you have to be in the wealth data for us to know it. And you only are in there if you're alive. But in this case, we're adding in about 100 observations of when both parents die between 1999 and 2006. And what's interesting is you can see, this is the biological parent. This is which is almost the same as our other coefficient in the previous specification. This is the adopted parent wealth. So this is the one for parents who are still alive now. That's what this is, which again is almost exactly the same as in the previous specification. And this is the difference once your parents die. And so the effect for parents, the correlation for adoptive parent wealth on children's wealth when the parents die is now up to 0.62 or 0.63. So dying, this inheritance component has a huge effect. Okay, so biology matters, environment matters more, and then when your parents die, that's a huge shock to your wealth. And so I think this isn't totally surprising, but this kind of, the inheritance component isn't driving this, but it clearly has a big bump to it. Okay, so then we think about different mechanisms. And so what we're going to do is kind of the not totally kosher thing, where you add controls and try to see how that changes our coefficients of interest. And so we're trying to see, like, and this is horrible and you shouldn't do this, grad students, because people are going to tell you it's a bad regression, which people tell us all the time. But it does kind of give you an idea of the correlation. So it's telling you how correlated are these things that are also might be affected by a parent's wealth. And so the first thing we do is look at parents' income and education and say, well, maybe we're measuring wealth, but what's driving this is parents' income and education. And they are highly correlated. So in our sample, the correlation is about 0.22 or 0.25. So they're pretty highly correlated. What's interesting is that once we control for parents' income and education, it doesn't change our coefficient on parents' wealth at all, which suggests that it may actually be wealth that matters in this context for children's wealth and not income or education. But again, this is suggestive. So what we do is we're going to add in other controls. The first ones we're going to add in is, okay, so this is, I'm going to move on. The first thing, so this is our basic specification that I showed you before. This is when we add in parents' income and education, added in for earnings, we add in as earnings rank. Then we started adding in kids controls. And what you see when we control for children's earnings and children's education is that that seems really important for the biological component, right? That's going down a lot, not so much for the environmental aspect. So it doesn't seem like it's through education or earnings. When we add in asset allocation, so the share of your assets in risky portfolios, we see that explains actually a reasonable amount of the environmental, the adoptive coefficient. So that's gone down to 0.17 from 0.23. And interestingly, when we add in the savings rate, it actually unexplains because they're saving less, not more, if your parents are wealthier. And then the last thing, we add them all in, and what we find is we can explain about 25%. And when I say explain, I mean air quotes explain, because this is not in any way kind of a well-identified thing. It's more a mathematical exercise of like, well, if we add in these potentially omitted variables or something like that, like how much does it explain? And it doesn't explain very much. Okay. So just to go through the robustness checks that are interesting, we look at different components of wealth, and it seems to be not driven by housing or financial assets. It's happening, the results are pretty similar for all of them. We didn't consider pension wealth because we're thinking about the wealth you can actually transfer, but when we add in pension wealth, because they have very generous pension system in Sweden, you'll see that the biological effect basically goes away, and so there's a big environmental aspect, but the pension wealth is kind of equalizing that biological aspect. We spend, as I said, a lot of time thinking about non-random assignment of adoptees. And even if our estimates are biased, it's by a very, very tiny amount because we are able to control for the biological parents' wealth. If we weren't, we would be more biased. So this is kind of cool, so I want to talk about this a little bit. The age of measurement of wealth. So we know that this is the average net wealth by age for the full sample of parents, and this is average net wealth by age for the full sample of children. So obviously, our parents are older and our kids are younger, but not surprisingly, these are positively sloped, a lot flatter in this age range, right? So once you're past like 60, it's pretty flat in terms of your average net wealth. But this does suggest that when you measure, the kids might really matter, or even the parents if you're looking at kind of young parents versus old parents. It might affect kind of our results. And so what we did is we looked at, we can't do this on the adoption sample, but we can do it on the biological kids where we have 1.2 million observations. And what we do is we break the sample, this is by children, so this is at each different age for children. We calculate what the correlation is between the child's wealth rank and the parent's wealth rank to see if it's kind of changing depending on where you are. So if you thought that there's a lot of noise in the rank here, you might expect a smaller correlation than as they get older. And this is striking to us, and the blue is the left, for those who are colorblind, is the not trimmed sample, and the right is the trimmed sample, so taking that 5% out. And what was striking to me is how flat this is. Like, it really does not seem to matter what age you measure net wealth. And this is something that others have noted, that there's a paper that actually suggests that even in your teens, your rank in your wealth is actually a reasonable measure of what your rank will be in the future, which seems crazy to me. But importantly for us, it doesn't seem like this is going to matter. For parents, when we break by parents' age, it seems like it might matter a little bit. Right? Up in this younger, right, when the parents are younger relative to here, and then when they're much older, right, and they're decreasing perhaps. But so what we can do is we test this econometrically, and we basically say, is the correlation different if you're a young child versus an old child? Is the correlation different if you're a young parent versus an old parent for the adoptive parents? And what we're going to find is that these interaction terms are basically zero. So it doesn't seem like the age of wealth is mattering. Okay? We also look at different transformations of net wealth. So some people don't like the rank because it is kind of a weird measure if you think about it, right? It's like, so at the bottom, the difference between the third percentile and the fourth percentile is probably, the difference in wealth is probably very different than between the 98th and 99th. So it's kind of this artificial unit of measurement. And so what we can do is look at kind of more standard measures. What we do is we look at the inverse hyperbolic sign, which is really like the log, but lets you deal with negative values, because we don't want to throw out all the negative values and zeros, because that would be a lot of our data. And we also look at levels. When you look at this in the data, when we plot it, it does not look linear. So we're kind of imposing a linear structure on this. We've tried also to allow for some nonlinearity, but because we don't have that many adoptees, we can't do too much in terms of nonlinearities. But what you'll see is when we do, let's take the trims, this is the trimmed sample, and we do levels and the log essentially. So you can view this as, its interpretation is like a log, so like an elasticity. We have the full sample of biological children, and you can see that the correlation is smaller than in the US if you think about what the the literature in the US was like 0.37. This sample, it's 0.25 for this correlation, the elasticity. But what you see is you still draw the same conclusion, that adoptive parental wealth is more important in terms of child's wealth relative to biological parent. When you look at levels, this is really hard. So first, I wouldn't even spend too much time on this because there's some real outliers in wealth when you look at levels and you don't trim the data. But you can see the general pattern on the trim. In both, the general pattern is about the same. Okay, and then the last things that we do is do common geographic shocks. So if you and your parent are living in a very expensive area, it might look like your wealth is correlated, but it's just because you're living in this area. So we look at within geographic areas and the results are the same. We look at average wealth across years instead of using 1 year. We spend a lot more time now in our recent work on these nature-nurture interactions. And so we really wanted to find something here because I think this is just fundamentally interesting and important. In our data, we aren't able to, even when we look at a whole bunch of other outcomes. And so this is the last slide that I'm going to present because this is our brand new stuff, so it is not out yet in public. This is its first coming out. We basically said, okay, here's our wealth rank. This is what we've done so far. Let's think about how that fits in the context of the intergenerational mobility literature more broadly. And so we're plotting the biological parents' correlation against the adoptive parents' correlation. And we're using a common sample and our data and common methodology, so these all should be relatively comparable. And so this 45-degree line says where they are equal. So biology has an equal weight relative to adoptive correlation. So both are equally important. And what's interesting is you can see that wealth is different in that when you look at wealth rank, and then that's wealth with inheritances, huge environmental aspect, right? They're pretty far from the 45-degree line. Consistent with other work, schooling and whether you attend a university is more biology. So in all of these, both matter, right? So we're not saying that they don't, but biology is more important, so it seems like there may be more of an inherent skills component. We've also done some new outcomes. So this is risky market participation and risky share rank. This is whether you participate in the stock market, even if it's just through mutual funds, but with the stock market component. And this is the share of your assets in risky allocations. So that's what we did in our other paper. The earnings rank is what other people have done that we found consistent results. We also added the savings rate rank and the consumption rank, and this is interesting. It seems like things associated with wealth and wealth management have an environmental component. This are stronger environmental component. Things that are schooling related seem to have more biological component. And then when we look at consumption as our last outcome, and this is kind of new results, we thought of that as kind of a general measure of well-being, like, so how much are you consuming? And so, and we're able to calculate this because we have such detailed account of income and assets. So it's not based on the survey, it's based on kind of how much you get that you don't then save into the future. And we see that that has a little bit more environmental, but also has a strong biological component. And so it seems like wealth has a much more environmental aspect to it, whereas things like schooling and earnings may be a little more biological. And so to conclude, I think I'm exactly on time. When we examine intergenerational transmission of wealth, we find a substantial role for environmental influences and a smaller role for biological influences. Once we add in inheritances, the environmental component becomes much bigger. I don't think that's surprising, but it's kind of cool to see in the data. We're kind of mushy about the exact mechanisms underlying it, more difficult to ascertain. If you wanted to take what we're doing at face value, we could say that we find evidence that parental wealth influences children's education and income. So So we find some effect, right? The coefficient goes down by a little bit for that. Asset allocations seem to matter. And then we found that savings actually goes in the opposite direction. Unlike human capital accumulation, which seems to be disproportionately driven by biology, wealth and associated measures, so savings rate and portfolio allocation, appear to be driven more by environment. So that's kind of the big picture of what we know about nature versus nurture. Okay. I was told to stop.